Hello students, today we will discuss a small concept of electrostatics, it is electric flux. Before we understand what is electric flux, let's see a meaning of a term which is area vector. What is this area vector is? Area is basically a scalar quantity. Area is what we studied is area vector is basically a scalar quantity. If you have an area like this, let us take this is the area. It is area like this. Area or small portion of this area also we can consider. If I consider a small portion of this area, let us take this is the area of this surface is delta S. Area of whole surface is S. Area of this surface is delta S. Or you can take it like this. If it is like this, a small portion of area I am considering. This is delta S. Area is like this. We conveniently choose a vector here, which nothing but area vector. If I say this area is delta S like this, if I draw a line which is perpendicular to this area or perpendicular to this area like this, a line which is drawn perpendicular to a given surface or normal to a given surface or normal to a small portion of the surface. This line is called as area vector. Area vector is a normal drawn to a given surface or portion of a surface. Portion of a surface. Then if I take this as area, let me define what is area vector. This area of this portion selected is delta S. What is the direction? Delta S is this area. Then its area vector is denoted by delta S with arrow mark. Delta S is area. Delta S with arrow mark represents area vector. This area vector I will write it like this. This will be a unit vector n cap multiplied by delta S, where n cap is a unit vector which indicates or which represents the direction of delta S vector. Delta S vector, or what is n cap is? N cap is a unit vector normal to the given surface. That means n cap is a unit vector drawn to the normal to the given surface. This delta S is area vector which is along n cap. That means what is n cap? N cap is a normal drawn to the surface. That means area vector is along n cap. N cap is along normal. It means that area vector is along normal. To any given surface, if you draw a perpendicular line, that perpendicular line will represent area vector. Suppose if this is open surface, if it is an open surface, you can draw the area vector in both sides. This is also delta S, this is also delta S. Then if it is a closed surface like spherical body or cubic body is there, spherical or cubic body, the surface is plane. If surface is spherical, then you will divide every spherical area into small portions. See, this is a spherical surface. We'll divide this into small portion so that each portion will appear like a planar surface. Then to this delta S, we'll draw a line perpendicular to the surface which represents area vector. Okay. For open surface, area vector can be drawn on the both sides. If it is a closed surface like spherical body or cubic body, to any portion, to any area, suppose if to this area if you draw the surface, it will be always drawn normal. Okay, this is area is S or area is A, means area vector will be equal to n cap into A, and it is only drawn outward. If it is a closed surface, then area vector direction will be a normal in outward direction. If it is an open surface, you can draw it on the both sides. Remember only this much. What is area vector is? If it is a surface like this, if you draw a perpendicular line, this represents area vector. If it is surface like this, area vector can be like this. If it is a cube, then to every surface you can draw the area vector. If it is a cube like this, area vector to this surface, area vector to this surface. That means they must be drawn outward, not this side. For a closed body, area vector to any portion of area, any area or any part of area will be always a normal in outward direction. This you remember. Then now we will come to know what is what is electric flux, that we will try to explain. See, what is electric flux? Suppose I have an electric field here. This is a uniform electric field. Like this. This is a uniform electric field. In three cases I am taking. This is a uniform electric field, E. This is also the same field, E. This is the uniform electric field. Let us change its direction. Let us see. In these two uniform electric fields, let us suppose I am holding a small portion or small area. The area of this will be delta S. Then where is its area vector? What is area vector? Perpendicular. Suppose if it is held like this, area vector is held perpendicular like this. This is the direction of area vector. Okay? Along the field. Then here what I am doing. I hold the, suppose field is in this direction. Electric field lines are passing like this. Once I hold the area, I am holding the area like this, so that E and ds will be in the same direction. And in the second case, what I will do, I will tilt this surface like this. That means if surface is held like this, lines are passing like this. Suppose that 100 lines are passing through this surface like this. If it is tilted, then some lines will pass like this and some lines will miss. See, if it is held like this, all the lines will be passing through the surface. How many lines? 100 lines. Let us suppose 100 lines. If surface is tilted like this, then some lines will be passing from above the surface, some lines will be passing from below the surface, and some lines will be missing. Suppose if surface is made like this. Same surface, I am tilting it like this. If surface is tilted, Then direction of electric field remains same. If the surface is tilted like this, see, this is the surface, huh? This is area vector. If surface is tilted like this, area vector also gets tilted. Then this will be area vector. Now, this is delta S. And this is still electric field. And this electric field is making some angle with area vector now. Then in third case, what I will do? In third case, we will keep the area same. I am not changing the orientation of area. I am changing the direction of electric field. If electric field is drawn like this, keeping area same. So now this will be the direction of area vector. Let us suppose this is the line drawn perpendicular like this. This is electric field line and this is electric field. This is area vector and this is electric field. And this line I am extending like this. This is the direction of electric field. This is area vector. Then this is the angle vector. In the first case, area vector and electric field are in the same direction. Now in the second case, area vector is making some angle with the electric field. In the third case also angle remains same. In this case I tilted the area. In this case I changed the direction of electric field. Then how many lines will pass through this surface? How many lines will pass through this surface? If I am holding any area in any orientation, the number of lines passing over an area which is placed in an electric field, the number of lines passing, suppose if I hold the area in the electric field like this, how many lines will be passing through this area? How many lines will be passing through a particular area which is held in the electric field? That quantity is called as electric flux. So what is electric flux? Generally denoted by letter this phi. What is electric flux? This area I am taking it as delta S. This area I am taking it as delta S. Then what is electric flux? Electric flux is defined as the number of field lines here. I will define it like this. Electric flux is the number of field lines passing through a surface or area, passing through a surface area which is held in an electric field. How many lines will be passing through this surface area which is held in the electric field? If it is held in the electric field in any orientation, if it is held in the electric field, just we will count the number of lines passing through this surface. If 10 lines are passing through this surface, then we say that flux is 10. If 100 lines are passing through this surface, then we say that flux is 100. The number of lines passing through this surface itself is indicating itself, it is defined as flux. Defines the flux. How many lines will be passing? That is nothing but flux. How many lines will be passing through this surface? That is called as flux. And that flux depends on which quantity is. Suppose if the field is strong, then number of lines will be more. More number of lines means if field is strong, number of lines will be more. That means flux will be more. Stronger field, more number of lines will pass through a given surface area. That means flux is more. In the same field, if I hold a small area and if I hold a large area, in the same field, see, this is the given field. In this field, I am holding this much area. 50 lines will pass through this area. If I hold the area like this, how many lines will pass? All the lines will pass through this area. Because 100 lines will pass. Less area, less number of lines. More area, more number of lines. That means how many lines will pass through this surface will be depending on E into ds, or is proportional to E delta S. If E is more number of lines will be there. If delta S is more, then also the number of lines passing through the surface will be more. Then, if I tilt the surface, see, I kept field as it is, area as it is. What I am changing is orientation of area. If I change the orientation of area also, the number of lines will be different. See, how many lines will be passing? All the 100 lines will be passing. If I hold it like this, some lines will be missing. That means electric flux had changed. Electric flux means what? Number of lines passing through the surface. Number of lines changed. If I hold it like this, some lines will pass from above the surface, some lines will pass from below the surface. No lines will be passing through this. That means flux becomes 0. How many lines will passing through this surface is itself called as flux. If 100 lines are passing, then we say that flux is 100. If no lines are passing, if it is held like this in the field, some lines will go above the surface, some lines will go below the surface, but no lines will be passing through this surface like this. That means, if this is delta S, see, if I resolve this delta S into two components, one along the field, delta S cos theta, one perpendicular to the field, delta S sin theta. Here also, if I resolve electric field like this is field perpendicular, E sin theta. This is field parallel to the delta S, E cos theta. See, when I resolve this area into two components, which component is along the field? Delta S cos theta is along the field. Here E cos theta is along the surface. How many lines will be passing through this surface will be decided by the component of area vector which is parallel to the field, not perpendicular. Suppose if it is held perpendicular, no lines will pass. If it is held like this, how many lines? This is delta S. This is delta S cos theta, this is delta S sin theta. How many lines will be passing? That will be along the delta S cos theta. That means number of lines also depends on theta. See, overall, this number of lines passing through this surface, which is nothing but flux, is depending on field strength, depending on area, is depending on theta also. Which component will decide how many lines will pass? See, this is the surface, this is delta S. This is delta S cos theta, this is delta S sin theta. Field is like this. How many lines will pass will be decided by delta S cos theta. That means total number of lines passing through this surface can be expressed as E delta S cos theta, or it is also expressed as delta S, keeping as it is, it will be E cos theta. This component or the component of electric field which is along delta S. This is the component of area vector along the field. Then overall I can write this as E delta S cos theta, which is nothing but E delta S. AB cos theta is nothing but A dot B. Make a note of this. This gives me the formula of how many lines will be passing through this surface. Okay. Then we will study the units and dimensions. Make a note of these things. Noted this? Can I repeat? Let us see. This is the component of, once again you remember, the component of delta S which is along the field, or the component of electric field which is along delta S. That component will decide how many lines will be passing. Therefore, formula becomes electric flux is equal to E delta S cos theta, or E dot S. Then flux will be given by electric field into delta S cos theta. Cos theta has any no dimensions, no units are there according to SI unit. Then this will be, what are the units? Units you can write for delta S is for phi. What is the E? Electric field Newton per Coulomb into area. This has no units, meter square. You can write this, okay. Or you can write dimensions also. Electric field into areas. Electric field into area. Electric field is Newton per Coulomb. Area is meter square. You can write dimensions also. Dimensions, what are the dimensions of the flux? This is flux is equal to electric field into area will take. Electric field into area. Or just write E into S. Flux is equal to, what is E? Force by charge. Force means what again? mLT minus 2. What is charge? A into T. Charge is equal to current into time. Current is A into, what is area? This is L square. Then phi is equal to, what is the final? M. This will be L cube. This is T minus 3, A minus 1. These are the dimensions. Units and dimensions of electric flux. Force by charge. Okay. Then, if I have a body like, suppose this is delta S is a portion of area. If I have a body like this, for a given surface, for a given body, you can say, for a given body, this I can write it as delta phi. That means I am calculating through a small area. If you can make it delta phi. Delta phi means small flux through a small area. For a given body, if you want to calculate entire flux, suppose that we have three surfaces like this. Here we have another one surface delta S, another surface delta S. These are the spherical surface. Another surface will be there. This is curved surface. Circular face, curved surface. Then if you take a cube, 6 surfaces will be there. If you want to calculate the total flux through a given body, the total flux will be given by, this will be E, I will keep it as it is, or I will apply sigma to entire quantity. Sigma of E into delta S cos theta, or E dot S. Then if I divide this area, so suppose that area is S. If I divide the area of this sphere into very small portions like this, this is a delta S, this is delta S, this is another delta S. If I divide the area into very small portions, if delta S tends close to 0, very small portions, then in place of delta S, I can write ds. Big changes, delta S. Very small quantities are there, means in physics we will use ds. See, ds is a very small. Then I can write d phi is equal to, I can write this as E ds cos theta. to get the exact value of phi, we'll integrate this quantity. This is E ds cos theta, or I can write this as E into E dot ds. And in some books you will find a circular mark on the integral sign, which indicates that this we are calculating through the closed surface. Flux through a closed surface will give the integration, will be given by integration of E dot ds. Cos theta is angle between E and ds, that you remember. Okay, this gives the flux through whole body. Or you can use this formula. If I take delta S as small enough, large enough quantities are there, then you can use. If area is divided into very small portions, so that delta S tends to 0, then phi will be given by this formula. Okay, this is about electric flux, its definition, formula, units and dimensions. Using this formula you can calculate electric flux. Then in the next video we will discuss what is Gauss theorem, and we will solve some NCERT examples based on electric flux and Gauss theorem. Okay, thank you.